Dennett believes that there are no good arguments for the existence of God. But insofar as we mean by a good argument, an argument which is, 1, formally and informally valid, 2, consists of true premises, and 3, has premises that are more plausible than their contradictories, there do appear to be good arguments for God's existence. And there are on the contemporary scene plenty of philosophers who think so. In my paper, I examine several of these, but in my oral presentation this morning, I'll have the time to only cover just a few. First, then, the cosmological argument. And I'm not sure who's running the PowerPoint. Am I supposed to do it with this thing, or, pardon me? I am. Okay, and how does it work?
Turn on the back.
Okay.
Look at that.
Okay. What do I aim this thing at?
Just the balcony, I guess.
Okay, good. All right. The cosmological argument is a family of arguments which seek to demonstrate the existence of a sufficient reason or first cause of the existence of the cosmos. A simple statement of a Leibnizian type cosmological argument might run as follows. 1, everything that exists has an explanation of its existence, either in the necessity of its own nature or in an external cause. 2, if the universe has an explanation of its existence, that explanation is God. 3, the universe exists, therefore, the explanation of the existence of the universe is God. Is this a good argument? Premise 1 is a modest version of the principle of sufficient reason, which circumvents the typical objections to strong versions of that principle. For one requires merely that any existing thing have an explanation of its existence. This premise is compatible with there being brute facts about the world. What it precludes is that there could exist things which just exist inexplicably. According to one, there are 2 kinds of being: necessary beings, which exist of their own nature and so have no external cause of their existence, and contingent beings, whose existence is accounted for by causal factors outside themselves. Numbers might be prime candidates for the first sort of being, while familiar physical objects fall under the second kind of being. This principle seems quite plausible, at least more so than it's contradictory. One thinks of Richard Taylor's illustration of finding a translucent ball while walking through the woods. One would find the claim quite bizarre that the ball just exists inexplicably, and increasing the size of the ball, even until it becomes coextensive with the cosmos, would do nothing to obviate the need for an explanation of its existence. Crispin Wright and Bob Hale, while recognizing that explicability is the default position and that exceptions to the requirement of an explanation therefore require justification, nonetheless maintain that an exemption is justified in the case of a contingent universe. For the demand for an explanation of the contingent universe is preempted by the restrictive principle that the explanation of the obtaining of a physical state of affairs must advert to a causally prior state of affairs in which it does not obtain. This principle would require that any explanation of the existence of the universe must advert to a causally prior state of affairs in which the universe does not exist. But since a physically empty world would not cause anything, they say, the demand for an explanation of the universe becomes absurd, and thus the demand for an explanation is preempted. This line of reasoning, however, plainly begs the question in favor of atheism. For apart from that assumption, there is just no reason to think that a causally prior state of affairs must be a physical state of affairs. The theist will regard Wright and Hale's principle as not at all restrictive, since the explanation of why the physical universe exists can and should be provided in terms of a causally prior, non-physical state of affairs involving God's existence and will. Premise 2, which was if the universe has an explanation of its existence, that explanation is God, is in effect the contrapositive of the typical atheist response to Leibniz, that on the atheistic worldview, the universe simply exists as a brute contingent thing. Atheists typically assert that, there being no God, it is false that everything has an explanation of its existence. For the universe, in this case, just exists inexplicably. In affirming that if atheism is true, then the universe has no explanation of its existence, atheists are also affirming the logically equivalent claim that if the universe has an explanation of its existence, then atheism is not true. That is to say, God exists. Hence, most atheists are implicitly committed to premise 2. Moreover, 2 seems quite plausible in its own right. For the universe, by definition, includes all of physical reality, and therefore the cause of the universe must, at least causally prior to the universe's existence, transcend space and time, and therefore cannot be physical or material. But there are only 2 kinds of things that could fall under such a description, either an abstract object or a mind. But abstract objects do not stand in causal relations. Therefore, it follows that the explanation of the existence of the universe is an external, transcendent, personal cause, which is one meaning of God. Finally, premise 3 states the obvious, that there is a universe. Since the universe exists, it follows that God exists. Now, although I haven't read all that Professor Dennett has written, I've not been able to find in his writings any response to this version of the cosmological argument apart from the following sentence, quote, "If why something exists rather than nothing is intelligible, then the answer, because God exists, is probably as good an answer as any. But look at its competition. Why not?" End quote. This is an amazingly conciliatory response. Dennett says nothing to show that the question is unintelligible, and if the theistic answer is as good as any answer that can be given to this question, then the theist will find himself so far forth as justified in his views as any atheist. But what about the atheist competition? Well, look at it. The counter question, why not, is ambiguous. Is the atheistic answer the claim that the universe just exists as a brute contingent? Then it runs afoul of the plausible version of the principle of sufficient reason stated in premise 1. Or is the atheist answer the claim that the universe exists by the necessity of its own nature? This would be an extremely bold suggestion which atheists, including Dennett, have not been eager to embrace. We have, one can safely say, a strong intuition of the universe's contingency. A possible world in which no concrete objects exist certainly seems conceivable. We generally trust our modal intuitions on other matters with which we are familiar. If we are to do otherwise with respect to the universe's contingency, then the non-theist needs to provide some reason for such skepticism other than his desire to avoid theism. Now, much more should be said about this, but I think that the atheistic answer to the question as to why anything at all exists strikes me as less plausible than the theistic answer. The premises of this Leibnizian version of the cosmological argument all seem more plausible than their negations. It therefore follows that the explanation for why the universe exists is to be found in God. Another version of the cosmological argument, which I have called the Kalam Cosmological Argument, constitutes an independent argument for a transcendent creator of the universe. The Kalam Cosmological Argument can be formulated as follows. 1, whatever begins to exist has a cause. 2, the universe began to exist. 3, therefore, the universe has a cause. Conceptual analysis of what it means to be a cause of the universe then aims to establish some of the theologically significant properties of this being. Now, premise one seems obviously true, at least more so than its negation. It is rooted in the metaphysical intuition that something cannot come into being from nothing. To suggest that things could pop into being uncaused out of nothing is to quit doing serious metaphysics and to resort to magic. Furthermore, if things really could come into being uncaused out of nothing, then it becomes inexplicable why anything and everything does not come into existence uncaused from nothing. Finally, the first premise is constantly confirmed in our experience. Atheists who are scientific naturalists thus have the strongest of motivations to accept it. Dennett, in his all too brief critique of the cosmological argument, misstates the first premise as everything that exists must have a cause, which occasions his obvious retort, what caused God? This is merely to caricature the argument. In fact, apart from certain Enlightenment thinkers, or Enlightenment rationalists, who by cause merely meant sufficient reason, no orthodox theist has ever asserted that everything has a cause, or that God is self-caused, a notion rightly rejected by Aquinas as metaphysically impossible. Nevertheless, it is noteworthy that Dennett does not think that the universe popped inexplicably into being, uncaused out of nothing. On the contrary, he affirms the first premise, stating that a being, quote, outside of time is nothing with an initiation or origin in need of explanation. What does need its origin explained is the concrete universe itself, end quote. Dennett rightly sees that a being which exists eternally, since it never comes into being, has no need of a cause, as do things which have an origin. So Dennett affirms the first premise, which will lead him, as we shall see, to the remarkable position that the universe must have caused itself to come into being. Premise 2 may be supported by both deductive philosophical arguments and inductive scientific arguments. Since the latter are apt to be more appealing to Dennett as a scientific naturalist, and since he never discusses the philosophical arguments for the finitude of the past, and most of all, since I am short on time, let me focus on the scientific arguments. One empirical argument for the beginning of the universe is based on the expansion of the universe. The standard Big Bang model describes a universe which is not eternal in the past, but which came into being a finite time ago. Moreover, and this deserves underscoring, the origin it posits is an absolute origin ex nihilo. For not only all matter and energy, but space and time themselves come into being at the initial cosmological singularity. There can be no natural physical cause of the Big Bang event, since, in Quentin Smith's words, it belongs analytically to the concept of the cosmological singularity that it is not the effect of prior physical events. The definition of a singularity entails that it is impossible to extend the space-time manifold beyond the singularity. This rules out the idea that the singularity is an effect of some prior natural process, end quote. Sir Arthur Eddington, contemplating the beginning of the universe, opined that the expansion of the universe was so preposterous and incredible that, quote, I feel almost an indignation that anyone should believe in it, except myself, end quote. He finally felt forced to conclude, and I quote, the beginning seems to present insuperable difficulties unless we agree to look on it as frankly supernatural, end quote. Sometimes objectors appeal to non-standard models of the expanding universe in an attempt to avert the absolute beginning predicted by the standard model. But while such theories are possible, it has been the overwhelming verdict of the scientific community that none of them is more probable than a model with an absolute beginning. Indeed, the history of 20th century cosmology can be viewed as one failed attempt after another to avert the absolute beginning predicted by the Standard Model. According to Stephen Hawking, and I quote, "Almost everyone now believes that the universe and time itself had a beginning at the Big Bang," end quote. Moreover, a watershed of sorts appears to have been reached in 2003 when Arvind Borde, Alan Guth, and Alexander Vilenkin successfully formulated a theorem which establishes that any universe which has, on average, over its past history, been in a state of expansion cannot be infinite in the past, but must have a past space-time boundary. This is a theorem of great power which applies alike to oscillating models, since over time the oscillations increase in size, to inflationary models, and to higher dimensional brane cosmological models based on string theory, as well as to typical expansion models. Vilenkin pulls no punches, quote, "It is said that an argument is what convinces a reasonable man, and a proof is what it takes to convince even an unreasonable man. With the proof now in place," still quoting Vilenkin, "cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning," end quote. We thus have strong empirical grounds for accepting the truth of premise 2 of the Kalam Cosmological Argument. It follows from the two premises that therefore the universe has a cause of its existence. Dennett, as we have seen, agrees, but he claims the cause of the universe is itself. The universe brought itself into being. Dennett writes, "What does need its origin explained is the concrete universe itself. And as Hume's Philo long ago asked, why not stop at the material world? It does perform a version of the ultimate bootstrapping trick. It creates itself ex nihilo, or at any rate out of something that is well nigh indistinguishable from nothing at all," end quote. Here, Dennett spoils his radical idea by waffling at the end. Maybe the universe did not create itself out of nothing, but at least out of something well nigh indistinguishable from nothing. This caveat evinces a lack of appreciation of the metaphysical chasm between being and nothingness. There is no third thing between being and non-being. If anything at all exists, however ethereal, it is something and therefore not nothing. So what could this be? Dennett doesn't tell us. In fact, he seems somewhat impatient with the question. He complains, "This leads in various arcane directions into the strange precincts of string theory and probability fluctuations and the like at one extreme, and into ingenious nitpicking about the meaning of cause at the other. Unless you have a taste for mathematics and theoretical physics on the one hand, or the niceties of scholastic logic on the other, you are not apt to find any of this compelling or even fathomable," end quote. How strange to indict an argument because it appeals only to the inquisitive and the intelligent. In a word, to the brights. In any case, however, the appeal of the argument is irrelevant. Even if Dennett's complaint were correct, it constitutes at best a piece of friendly atheistic advice to theists about the limited utility of the Kalam Cosmological Argument in evangelism. We can thank Professor Dennett for his advice while still demanding an account of the origin of the universe. The best sense that I can make out of Dennett's suggestion is to construe it as an endorsement of a model of quantum creation such as is offered by his Tufts University colleague, Alexander Vilenkin. Vilenkin invites us to envision a small, closed, spherical universe filled with a false vacuum and containing some ordinary matter. If the radius of such a universe is small, classical physics predicts that it will collapse to a point. But quantum physics permits it to tunnel into a state of inflation. If we allow the radius to shrink all the way to zero, there still remains some positive probability of the universe's tunneling into inflation. Now, Vilenkin equates the initial state of the universe explanatorily prior to tunneling with nothingness. Unfortunately, this equivalence is clearly mistaken, and perhaps Dennett's waffling betrays his understanding of this fact. As Vilenkin's figure 17.1 in his recent book illustrates, the quantum tunneling is at every point a function from something to something. For quantum tunneling to be truly from nothing, the function would have to have only a single term, the posterior term. Another way of seeing the point is to reflect on the fact that to have no radius, as is the case with nothingness, is not to have a radius whose measure is zero. Thus, on Vilenkin's model, we are still left wondering what caused the initial state of the universe to come into being. Dennett's answer is the universe, in the ultimate bootstrapping trick, created itself. Dennett's bold hypothesis would at least help to resolve A.N. Pryor's objection that if something can come into being out of nothing, then it becomes inexplicable why anything and everything does not come into being out of nothing. On Dennett's view, the coming of the universe into being is causally constrained. It creates itself. Of course, that still leaves us wondering why other things, say bicycles and hot dogs and unicorns, do not have that same capacity. But never mind. As Aquinas argued, self-creation is metaphysically absurd, since in order to cause itself to come into being, the universe would have to already exist. One is thus caught in a vicious circle. Aquinas made the point with respect to an eternally existing universe. But his argument is even more forceful with respect to a universe with a beginning. For in the latter case, the universe must be not only explanatorily prior to itself, but even, it seems, chronologically prior to itself, which is incoherent. Thus, Dennett's imaginative suggestion is wholly implausible. It therefore follows that the universe has an external cause. Conceptual analysis enables us to recover a number of striking properties which must be possessed by such an ultramundane being. For as the cause of space and time, this entity must transcend space and time, and therefore exist atemporally and non-spatially, at least without the universe. This transcendent cause must therefore be changeless and immaterial, since timelessness entails changelessness, and changelessness implies immateriality. Such a cause must be beginningless and uncaused, at least in the sense of lacking any antecedent causal conditions. Occam's razor will shave away any further causes, since we should not multiply causes beyond necessity. This entity must be unimaginably powerful, since it created the universe without any material cause. Finally, and most remarkably, such a transcendent cause is plausibly taken to be personal. 3 reasons can be given for this conclusion. First, there are 2 types of causal explanation: scientific explanations in terms of laws and initial conditions, and personal explanations in terms of agents and their volitions. A first state of the universe cannot have a scientific explanation, since there is nothing before it, and therefore it can be accounted for only in terms of a personal explanation. Secondly, as we've already seen, the personhood of the cause of the universe is implied by its timelessness and immateriality, since the only entities we know of which can possess such properties are either minds or abstract objects, and abstract objects do not stand in causal relations. Third, this same conclusion is also implied by the fact that we have in this case the origin of a temporal effect from a timeless cause. If the cause of the origin of the universe were an impersonal set of necessary and sufficient conditions, it would be impossible for the cause to exist without its effect. For if the necessary and sufficient conditions for the effect are timelessly given, then their effect must be given as well. The only way for the cause to be timeless and changeless, but for its effect to originate anew a finite time ago, is for the cause to be a personal agent who freely chooses to bring about an effect without any antecedent determining conditions. Thus we are brought not merely to a transcendent cause of the universe, but to its personal creator. Third argument, the teleological argument. Once thought to have been demolished by Hume and Darwin, the teleological argument for God's existence has come roaring back into prominence in recent years. Undoubtedly, it is the discovery of how complex and sensitive a nexus of initial conditions must be given in order for the universe even to permit the origin and evolution of intelligent life, which has served to reopen the books on the teleological argument. The discovery of cosmic fine-tuning has led many scientists to conclude that such a delicate balance of physical constants and quantities as is requisite for life cannot be dismissed as mere coincidence, but cries out for some sort of explanation. What is meant by fine-tuning? The physical laws of nature, when given mathematical expression, contain various constants, such as the gravitational constant, whose values are not mandated by the laws themselves. A universe governed by such laws might be characterized by any of a wide range of values for such variables. Moreover, there are certain arbitrary physical quantities, such as the entropy level, which are simply put in as boundary conditions on which the laws of nature operate. By fine-tuning, one means that the actual values assumed by the constants and quantities in question are such that small deviations from those values would render the universe life-prohibiting, or alternatively, that the range of life-permitting values is exquisitely narrow in comparison with the range of assumable values. Dennett therefore errs when he represents the argument from fine-tuning as based upon the elegance and precision of the laws of nature. The laws of nature may, as he suggests, be metaphysically necessary, but it is the contingent values of the constants appearing in those laws and the contingent boundary conditions on which those laws operate which are incomprehensibly fine-tuned for life and are the focus of interest. In a sense easier to discern than to articulate, this fine-tuning of the universe seems to manifest the presence of a designing intelligence. The inference to design is best thought of not as an instance of reasoning by analogy, as is often portrayed, but as a case of inference to the best explanation. John Leslie speaks of the need for what he calls a tidy explanation. A tidy explanation is one that not only explains a certain situation, but also reveals in so doing that there is something to be explained. Leslie provides a whole retinue of charming illustrations of tidy explanations at work. Suppose, for example, that Bob Stewart is given a new car for his birthday. Now, there are millions of license plate numbers, and it is therefore highly unlikely that Bob would get, say, CHT 4271 on his license plate. Yet that plate on his birthday car would occasion no special interest. But suppose Bob was born on August 8, 1949, and he finds on the license plate BOB 8849 on his birthday card. He would be obtuse if he shrugged this off with the comment, well, it had to have some license plate number, and any number is equally improbable. But what makes this case different than the other? Well, a full-fledged theory of design inference has recently been offered by William Dembski. Dembski's analysis can be used to formalize what Leslie grasped in an intuitive way. What makes an explanation a tidy one is not simply the fact that the explanandum is some improbable event, but the fact that the event also conforms to some independently given pattern, resulting in what Dembski calls specified complexity. It is this specified complexity, high improbability plus an independent pattern, that tips us off to the need for an explanation in terms of more than mere chance. An alternative approach to design inferences is offered by Robin Collins, who employs a Bayesian approach to argue that the cosmic fine-tuning is much more probable on the hypothesis of design than on the hypothesis of a single atheistic universe, and that therefore the evidence of fine-tuning strongly confirms design over its rival hypothesis. Regardless of which approach one adopts, the key to detecting design is to eliminate the two competing alternatives of physical necessity and chance. Accordingly, a teleological argument appealing to cosmic fine-tuning could be formulated as follows. 1. The fine-tuning of the universe is due to either physical necessity, chance, or design. 2. It is not due to physical necessity or chance. 3. Therefore, it is due to design. Now, since premise 1 seems to exhaust the alternatives, the cogency of this argument will depend upon the plausibility of premise 2. Can the cosmic fine-tuning then be plausibly attributed to physical necessity? Well, sometimes physicists do speak of a yet-to-be-discovered theory of everything, or TOE as abbreviated, but such nomenclature is, like so many of the colorful names given to scientific theories, quite misleading. A TOE actually has the limited goal of providing a unified theory of the four fundamental forces of nature, to reduce gravity, electromagnetism, the strong force and the weak force, to one fundamental force carried by one fundamental particle. Such a theory will, we hope, explain why these four forces take the values they do, but it will not even attempt to explain literally everything. For example, the most promising candidate for a TOE to date, superstring theory, or M theory, fails to predict uniquely our universe. Stephen Hawking recently addressed this question at a cosmology conference at University of California, Davis. Notice the alternative answers available to the question he poses. I quote, "Does string theory, or M theory, predict the distinctive features of our universe, like a spatially flat four-dimensional expanding universe with small fluctuations, or the standard model of particle physics? Most physicists would rather believe string theory uniquely predicts the universe than the alternatives. These are that the initial state of the universe is prescribed by an outside agency, codenamed God, or that there are many universes and our universe is picked out by the Anthropic Principle." Notice that these represent the three alternatives before us. Hawking shows that the first alternative is a vain hope. He says M theory cannot predict the parameters of the standard model. Obviously, the values of the parameters we measure must be compatible with the development of life. But within the anthropically allowed range, the parameters can have any values. So much for string theory predicting the fine structure constant. He wrapped up his talk by saying, "Even when we understand the ultimate theory, it won't tell us much about how the universe began. It cannot predict the dimensions of space-time, the gauge group, and other parameters of the low-energy effective theory. It won't determine how this energy is divided between conventional matter and a cosmological constant." So, to come back to the question, does string theory predict the state of the universe? The answer is that it does not. It allows a vast landscape of possible universes in which we occupy an anthropically permitted location, end quote. In fact, this idea of a cosmic landscape predicted by string theory has become something of a phenom in its own right. It turns out that string theory allows around 10 to the 500th power different universes governed by the present laws of nature, so that it is far from rendering the observed values of the constants and quantities physically necessary. Moreover, even though there will be a huge number of possible universes lying within the anthropically favorable boundaries, nevertheless, that life-permitting region will be unfathomably tiny compared to the entire landscape, so that the existence of a life-permitting universe is fantastically improbable. There is no reason to think that showing every constant and quantity to be physically necessary is anything more than a pipe dream. What then of the alternative of chance? This is Dr. Dennett's preferred option. Issues pertinent to the so-called Anthropic Principle arise here. Anthropic theorizers have come to realize that the Anthropic Principle can only be legitimately employed when it is conjoined to a many worlds hypothesis, according to which a world ensemble of concrete universes exists, actualizing a wide range of possibilities. Now, if the many worlds hypothesis is to commend itself as a plausible hypothesis, then some plausible mechanism for generating the many worlds needs to be explained. Dennett appeals to Lee Smolin's ingenious suggestion that if we suppose that black holes spawn other universes beyond our own, then universes which predict large numbers of black holes would have a selective advantage in producing offspring, so that a sort of cosmic evolution would take place. If each new universe is not an exact reproduction of its parent universe, but varies in its fundamental constants and quantities, then universes which are proficient in producing black holes would have a selective advantage over those which are less proficient. Thus, in the course of cosmic evolution, universes whose fundamental parameters are fine-tuned to the production of black holes would proliferate. Since black holes are the residue of collapsed stars, cosmic evolution has the unintended effect of producing more and more stars, and hence more and more planets where life might evolve. Eventually, observers would appear who marvel at the fine-tuning of the universe for their existence. Unfortunately for Dennett, Smolin's idea proved to be a non-starter. The fatal flaw in Smolin's scenario, wholly apart from its ad hoc and even disconfirmed conjectures, was his assumption that universes fine-tuned for black hole production would also be fine-tuned for the production of stable stars. In fact, the opposite is true. The most proficient producers of black holes would be universes which generate them prior to star formation, so that life-permitting universes would actually be weeded out by Smolin's cosmic evolutionary scenario. Dennett also floats the old idea from John Wheeler in 1974 of an eternally oscillating universe in order to secure an infinite past, during which various combinations of constants and quantities could have been tried ere this present system was struck out. Not only is he apparently unaware of the manifold problems which led to the demise of such oscillating models in the late 1970s, but such theories actually require fine-tuning in order to ensure an infinite regress of oscillations, and fine-tuning of a very special sort, since the conditions must be set non-causally at minus infinity. Moreover, as we have seen, the Borde-Guth-Vilenkin theorem mentioned earlier applies to such models, so that such models must have a beginning in the finite past and cannot be extended to infinity. And the same problem also afflicts inflationary cosmological models. Not only are the many worlds hypotheses therefore evidentially wanting, but they also face a potentially lethal problem, and with this I close. Simply stated, if our universe is but one member of an infinite world ensemble of randomly varying universes, then it is overwhelmingly more probable that we should be observing a much different universe than that which we in fact observe. Roger Penrose calculates that the odds of our universe's low entropy condition obtaining by chance alone are on the order of 1 chance out of 10 to the power of 10 to the power of 123, an inconceivable number. If our universe were but one member of a collection of randomly ordered worlds, then it is vastly more probable that we should be observing a much smaller universe. The odds of our solar systems being formed instantaneously by random collisions of particles is, according to Penrose, about 1 chance out of 10 to the power of 10 to the power of 60. A vast number, but inconceivably smaller than 10 to the 10 to the 123rd. In fact, Penrose calls it utter chicken feed by comparison. So that if our universe is just one member of a world ensemble, it is vastly more probable that we would be observing a much smaller universe. Observable universes like those are much more plenteous in the ensemble of universes than worlds like ours, and therefore ought to be observed by us if the universe were but one random member of an ensemble of such worlds. Since we do not have such observations, that fact strongly disconfirms the multiverse hypothesis. On naturalism, at least, it is therefore highly improbable that there is a world ensemble. For these reasons, the many worlds hypothesis is severely disabled as a candidate for the best explanation of the observed cosmic fine-tuning. Since the alternative of chance stands or falls with the many worlds hypothesis, that explanation does not commend itself. It therefore seems that the fine-tuning of the universe is plausibly due to neither physical necessity nor to chance. It follows that the fine-tuning is therefore due to design. Now again, much more deserves to be said about this, but I'm out of time, so let me simply conclude by saying it seems to me, therefore, that the theist is amply within his rational rights in believing that a personal creator and designer of the universe exists, who is the sufficient reason for why anything at all exists.
That is a virtuoso job. A stunning amount of careful articulation, structure of some dauntingly difficult issues. And ironically, though, I think it proves my point. What Professor Craig does brilliantly and with a wonderful enthusiasm is he takes our everyday intuitions, our gut feelings about what's plausible, what's counterintuitive, what couldn't possibly be true, and he cantilevers them out into territory where they've never been tested in cosmology, where whatever the truth is, it's mind-boggling. So we know in advance that whatever the truth is, it's going to be jaw-droppingly implausible and counterintuitive in one way or another. The simplest expression of this, I think, was due to the late Philip Morrison, who pointed out, perhaps we are alone in the universe. Perhaps there's no other planet in the whole universe that has intelligent life on it. Or perhaps that's not true. Both alternatives are mind-boggling. The hypothesis that we're alone is mind-boggling. The hypothesis that we're not alone is mind-boggling. So you can't use mind-bogglingness as your litmus test. The truth is going to be very hard to believe. And some of our home truths are going to have to be abandoned. We already know this from quantum physics. We already know this from Einstein. How do we get the leverage to find the epistemic sort of leverage to dislodge something that just seems so crashingly obvious we're prepared to use it as a premise? It takes a huge scientific structure with complex mathematical arguments and a sort of delicious conspiracy of confirmatory evidence, and finally people shake their heads and say, okay, however counterintuitive this is, we're going to have to accept it. That's the situation in quantum mechanics, as Richard Feynman, the late great physicist, said, and he was as arrogant a scientist as there ever was. He had a black belt in overconfidence. And he says, I don't understand quantum mechanics. Nobody understands quantum mechanics. Maybe nobody can. In those circumstances, you come to trust the mathematical theory that you can't interpret yet. Raging battles over how to interpret quantum mechanics. Unsettled. But, as Feynman points out, the mathematical structure, which is just in some sense a black box that we can't yet get to the bottom of, it predicts results of such breathtaking accuracy. His comparison, I won't get it exactly right, but I think it's like being able to measure the distance between San Francisco and Miami to a hair's breadth. Breathtakingly accurate predictions. Those are the sorts of just the weight of evidence that can overturn everyday intuitions that you just think, that couldn't possibly be false. But it turns out to be false. And what Professor Craig has shown us is how the arguments go and how, if you start with a bunch of initially very plausible premises, and in each case he says, look, this is a very plausible premise. I don't see how this could be false. This just stands to reason. And then you pursue it, and he does that. As near as I could see, I had no quarrels with the relentless development he puts on those premises. But we end up at really remarkably implausible conclusions. Now, officially, of course, if you end up with a self-contradictory conclusion, you've got a reductio ad absurdum argument, and something has to give. I cannot pin a formal reductio on anything, at least if I can't do it impromptu. There was an awful lot going on in that talk. But I can point to some areas of suspicion. First, I want to address one of the points that came up late. Maybe I'll just make that point, and then that will be enough. Let us suppose, for the sake of argument, that the cosmological argument, one of the cosmological arguments that he presents, does favor the conclusion that the cause of the universe is a timeless, changeless, abstract, immaterial, whatever. At that point, we have no idea what that might be. But whatever it is, it's the cause of the universe. Maybe it's the idea of an apple. Maybe it's the square root of 7. But no, he says, it's nothing like that, because abstract things can't cause things. Who says? Who says abstract things can't cause things? My favorite example of an abstract thing causing things is the principle of triangulation, so that when you want to keep your house from going like this, you put a triangular piece on and you tack it down, and then thanks to the rigidity of triangles, you create a rigid structure. It seems causal. It's quite wonderful, the effect of tacking that extra piece on and making the triangle, and now we've got a rigid figure. It's Euclidean geometry, an abstract principle being invoked in a causal way. But you say, well, that's not really causation. Okay, it's something like causation, And of course, we've already heard from Professor Craig, it's not really like causation when God causes the universe, because it's not it's not physical causation. Well, what do we know about non-physical causation? Nothing. Absolutely nothing. So we're really just guessing at what non-physical causation could be. Our intuitions just don't carry us into that area. Now, contemporary cosmology is a fascinating area, and I must say it completely twists my head up, and I have no confidence about anything in that area. I'm delighted that Professor Craig mentioned my colleague Alex Valenkin, who is one smart dude, and I wish I could get to the bottom of all of the stuff that Alex does. I wish Alex were here to respond, because I know that Alex and Alan Guth and some of these other people would have an awful lot to say. Unfortunately, it would be highly technical, and I don't think I would understand it, and I don't think most of you would understand it, but they, first of all, they wouldn't agree. Contemporary cosmology is in a wonderful snarl, and those of us who are not mathematicians and physicists are going to have to sit on the sidelines and wait for something to percolate out of this. The intrepidness with which Professor Craig leaps in there and chooses sides is a wonderful thing. I just don't have his courage on that point. But back to the question of this changeless God. The trouble with a changeless God is that it is changeless. It is outside of time. Don't bother praying to it, or certainly don't expect it in time to hear your prayer and answer your prayer. A changeless God is a deist God at best. So that's why I don't think that most people in the world who believe in God need take anything more than the most passing curiosity, interest in the battle of cosmology, because it doesn't really reflect a response to their curiosity at all. Now, Professor Craig says that he's got some arguments that this is a personal God. One of the premises is there's two kinds of causation: scientific causation and personal causation. I submit that that's just false. That's as good as my life work to show how personal causation reduces to scientific causation. So that's where I would drive the wedge in there, but that's a long story. Thanks very much.